Hello students. In this video we'll look at the isometric projection and isometric view of spheres. Okay, so we had already seen this image, that is, this is the two reference planes and the cube. Okay, the cube of 100 millimeter sides, and we had seen that how this cube, if we are just giving it an inclination, the isometric axis being inclined equally to the vertical plane, then we get what we call as the isometric projection. And that this 100 millimeter will in the isometric view, it will be represented as 82 millimeter, because it will be reduced to 82% of the true length. How does this happen? Because of the true length will not be visible when we are viewing that true length from an inclined angle. Okay, so here I have also introduced a sphere here. Okay, I have kept a sphere. So let us look from the front, that is the front view. So we have this cube also here, so that two vertical faces are equally inclined to the vertical plane, and we have a sphere here. Okay, to make it more interesting, I will also switch on the X-ray view here. Okay, so I had drawn a radius line, actually, from the point of the contact of the sphere with the horizontal plane, and to the actual center of the sphere I have drawn a radius line here. Okay, I've drawn from the center of the sphere to the point of contact of the sphere with to the horizontal plane. I have drawn a line that is actually the actual radius of the sphere. Okay, so if I switch, I can only view it if I'm switching on the X-ray view of the SketchUp application here. So that is that. And now, so as you know, this view here is not the isometric view, it's just this a simple front view of the same cube that we have here. So if I'm going to give it an inclination or view it from an inclined angle, you can actually see that this view will gradually change to this view here, the isometric view. So in order to get the isometric view, we are just viewing it from a different angle, right? So this dimension here, they are all 100 millimeter, right? I have already told you that this is 100 millimeter. This sphere is actually a sphere that I've drawn as of 80 millimeter diameter, and this sphere is 100 millimeter. So if I'm trying to view it from an angle, okay, I'll switch off the isometric. Okay, if I'm trying to view from an angle, you can see that the apparent view or the projected size of the pyramid is actually decreasing, because this, if you are actually drawing it as an orthographic projection, you will get that it is not 100 millimeter anymore. It will definitely be, if I'm getting the angles right, it will definitely be 82 millimeter in the isometric projection. Okay, because I'm viewing from a different angle. This is the isometric projection, because the angle has been the true lengths have been reduced in the apparent view. Okay, so now I want you to now look at this sphere. Has it reduced any length? Reduce its length in the in this angle? Okay, I'll just take it back to the original position. Okay, this is the original position here. This is the true front view. So if I'm trying to impart an angle to the view here, then slowly the projected length of the side is actually going on decreasing. At a particular angle, it will become the isometric projection. So let's say this in this angle, it is the isometric projection. So are you seeing any sort of reduction in the projected length of the sphere, projected size of the sphere? Again, look at it from the front. If I'm imparting an angle, are you seeing any reduction? No, the answer is no. Okay, because in any direction, the sphere has the same size. Okay, any angle we view, the sphere will have the same size. That is the reason why it is the isometric projection will not change. So basically, if you have to draw the isometric projection of a sphere, you don't actually have to reduce the length of the actual length. You don't have to reduce the actual length. It happens only in the other solids. In the case of sphere, you don't have to do it, and this is the reason, because in any view it will have the same size, unlike the other shapes and solids. Okay, so where will you have a change in the isometric projection? That for in order to notice that, I will switch on the X-ray view again. Okay, I'll go back to the front view. Okay, this is the radius, as I told you before. This is the radius from the center of the sphere to the point of contact of the sphere with the horizontal plane. Okay, so again now I'm going to impart an angle to the view. Okay, again I'm going to view it, and this is exactly the point where I have the isometric view, isometric projection, right? This horizontal diagonal has been coinciding with the other point. This we have here is what is the isometric projection. So what do you notice in the isometric projection of the sphere? You see that the size of the sphere is still the same. There has been no reduction. But what you can see is the radius that I drew inside the sphere. This point is still the center of the sphere, and this point here, the bottom part. Okay, this point here is still the point of contact of the sphere with the horizontal plane. It is the same line. But what has happened? That length has been reduced now to 82%. Okay, this length is 82% of the actual radius of the circle. But the isometric projection of the circle, it's the same size itself, actual size, that is 80 millimeter. But in the isometric projection, any other dimension that we are drawing inside the sphere, be it the diameter, okay, or be it the radius, all right, that will get reduced to 82% of the true value. So that happened here with this radius line also, that the radius line which was joining the center of the sphere to the point of contact with the horizontal plane. Okay, so again I will just show you once again. This is the front view. Okay, this is the true radius of the sphere. This is the true size of the sphere. This is the cube of 100 millimeter. The height is 100 millimeter. So if I am trying to make it into a isometric projection, so I am imparting an angle to the view. Okay, and this is approximately where we have the isometric view, right? Isometric projection. So this is the isometric projection. These lengths have been foreshortened, right? In this view, in the isometric projection, this has been reduced to 82%. Similarly, this radius line that I have drawn inside, that has been reduced to 82% also. But the size of the sphere still remains the same, because sphere in any direction it will have the same size, so it cannot be foreshortened. Okay, I hope this is clear in this demonstration. I'll just take you to a PowerPoint presentation to explain it further. So just show you further. Okay, isometric projection and isometric view of spheres. Okay, so isometric projection of any solid, the lengths are reduced to 82% of the true length, right? This is because lines are imagined to be inclined to the reference plane. So inclined lines, we will have it foreshortened. It will be reduced. So in the isometric projection, there is a particular angle at which it is inclined, and for that, the foreshortening is 82%. And then there is the isometric projection of the sphere. Here, the size of the sphere is not going to be reduced in the isometric projection, as a sphere will have the same size in any angle you view it. But all other dimensions or length within the sphere that we are drawing inside, like this radius line that we had shown in the demonstration, they will all be reduced to 82%. But there is another thing, as we know, isometric projection, we also draw isometric view. In case of isometric view of solids, what we have is, we usually take the true lengths only. We'll give that inclinations and all, we'll draw it at 30-degree angle with the horizontal line. All those things will be done, but we'll take the true length. That is known as isometric view. So there is another catch in the isometric view of spheres. Okay, in isometric view of sphere, all the dimensions or length within the sphere is taken as true length. Like in the case of this, in this case, this length, that is this foreshortened length, that is the radius. In the isometric view of a sphere, it will be taken as true length, true radius itself. Okay, 100% radius itself it will be taken. But again, you think about it logically. Except the size of the sphere, everything will be taken as true length. Except the size of the sphere. Size of the sphere will be enlarged to 122% of the true size. That is, you multiply the true radius of the circle. When you're drawing the sphere, you will just take the radius as 1.22 times the radius. Okay, why is it taken? Because isometric view is actually the true length, right? Think about it. If you are drawing the isometric projection from a isometric view of a sphere, right? So what should you do? You should just take 82% of that, right? So 1.22 into 0.82 will be equal to 1. Okay, so in order to get the isometric view of a sphere, you just have to draw a sphere with a radius which is equal to 1.22 times the actual radius, and all the other these lines such as these will be drawn in true length. Okay, I hope you understand the difference. I will also just do a problem here to further explain it. So a sphere of radius 30 millimeter is resting centrally on top surface of a square plate of side 70 millimeter and of negligible thickness. Draw the isometric projection and isometric view. Okay, so the first thing that I will do is draw the orthographic projection of this square plate and this sphere. So obviously I'll draw the XY line. Okay, I'll draw the square plate first, that is 75 millimeter. Okay, I'll just find its center. Okay, here I'll draw a radius, a circle of radius 30. Okay, all right, this was the top view. I will now draw the front view. Okay, so okay, then I'll just complete the front view also. The radius is 30, so 130, then circle. Okay, so this is the top and front view. Okay, now the question is draw the isometric projection and the isometric view. So in order to get the isometric projection, you will have to draw the isometric scale. So let me do that. So this is a horizontal line. Okay, so I have to get the isometric length of 75, so I'll just mark it 75. Okay, it will be taken down. Okay, so this length here is the isometric length of 75, that is 61. So I'll draw the isometric projections with the length 61. Okay. Okay. Then again, I will have to find the center point of this the square plate so that I can place the sphere. So just finding it. So before that, I'll just thicken this lines. Okay. Here is the center of the plate in the isometric projection. Okay. So then again, this here is the radius of the sphere from the center point of the sphere to the point of contact of the sphere with the square plate. Okay, this is the actual radius. This radius is 30. So as I've already told you, in the isometric projection you have to reduce that length. Okay, you have to reduce that length to the isometric length. So again I will do the same here in the isometric scale. I will mark 30. Okay. Okay, and then I'll measure this. This is 24. So 30 into 0.82, you get 24. This is the isometric length. Okay. So what you have to do next is you have to mark this from the center point of the plate upwards. You mark 24. Okay. You have drawn this line, this actual radius of the sphere, that is of radius 30 millimeter. You have changed that into isometric length by multiplying it with 0.82 or using the isometric scale here. Okay, and then as I've said previously in the demonstration, you are not supposed to reduce the size of the sphere. Size of the sphere should be the actual size itself. What is the actual size of the sphere? The actual size of the sphere is that it is a sphere of radius 30 millimeter. So you just have to draw from this point. So this point, the upper end of this line, is the actual center of the sphere. From that center you have to draw a circle of radius 30 millimeter. Type in 30. This is the sphere that I want. Okay, so I hope you got it. This is the actual radius. This line, that darkened line that I marked, is the actual radius that I've drawn here in the front view. Okay, this has been transferred here and reduced to 82%, but the actual circle, it will not be reduced. Even in the isometric projection, it will not be reduced. Okay, this is the isometric projection, it will not be reduced. So you can actually also mark these lines here. You can okay, I'll just draw the dimensions. Okay, this is 24. Okay, but this one will be of radius 30. Okay, this will be of radius 30, but the length here, that is depicting the radius joining the center of the sphere to the point of contact with the square plate, that will be reduced to 82%, that is 24. Okay, I hope this is clear. And I'll also have to, these edges of the square plate will be hidden, so I'll have to change that. Okay, okay, this is the isometric projection. I'll just mark it also. Okay, now I will try to draw the isometric view. Okay, the same thing. In the case of isometric view, for the square plate, I don't have to reduce it to 82%. I can take the true length itself. So what do? I take a point. The square plate is of 75 millimeter length, so 75 at 30 degrees. Okay, now the next step will be to find the center of the plate. Again. Okay, now what did I say in the previous discussion, that in the isometric view I'll have to take the actual length of this line, that is the line joining the center of the sphere to the point of contact to the square plate. That line is actually 30, so in the isometric view also I will be taking it as 30. Okay, so I'll now draw that is I'll draw a line from here with length 30. Okay, 30. Now again, in order to draw the sphere, obviously in the view this line is actually now inclined, so, and that line has been taken in its true length, that is of 30 millimeter. Now obviously the circle will be drawn at a radius that is larger than that. So in order to make that, keep that proportion, we are going to multiply the size of the sphere with 1.22. So what is 30 millimeter into 1.22? 30 millimeter into 1.22 is 36.6. Okay, so I'll draw a circle from here, keeping this as a center, that is the center point of the sphere as a center, and I will draw a circle of radius 36.6. Okay, and this becomes the isometric view of the sphere of size radius 30 millimeter. Again, I will mark the dimensions. I'll mark the dimensions so that it becomes more clear. This has been drawn with the true length 30. Meanwhile, the circle was drawn with radius 36.6, which depicts that the size of the sphere has been enlarged to keep up with the other ratios. Okay, it has been enlarged to by sort of 122 percentage. Okay, now again we have to make these edges hidden. So okay, this completes the isometric view. So I hope you understood the difference. Again, there are a few more dimensioning that I may be required to complete here. This is 61 because it has been reduced to the 75 millimeter has been reduced to 82 percentage of it. That is 75 into 0.82. That is 61. Okay, and here in this case, I have used the true length. That's the difference. Everything else had been taken in true length, but the actual size of the sphere that you have drawn has been enlarged by a multiple of 1.22 in the isometric view. But in the isometric projection, the size of the sphere was the same, that is radius 30, but all other dimensions was reduced to 82%. So know the difference. This is the solution for this question. Thank you.